Hi everyone, this is Mrs. Bustamante. Today we're going to quickly talk about something called percent error. And percent error is really just a way that's going to allow us to calculate or kind of tell us a little bit quantitatively, like with a number, about how good our data was. Were we really close to the value that we thought we should have gotten, or what we're going to call as our theoretical value or not? So you'll see we have this equation, and this equation is what we're going to use. Percent error is the absolute value, that's what these two lines on the outside mean, of our theoretical value minus our experimental value divided by our theoretical value times 100. That's how we get it into a percent. So really, I think you can do the math here. But what I want you to think about, and what sometimes is challenging, is what do these words mean? Okay, we're going to use this on your data. So when we use this on your data, it's from experiments that you did. So we can know that the experimental value, that's going to be the one that you got or you created or whoever in the hypothetical situation came up with. The theoretical value is the true value or the real value, the one that you would find printed on textbooks and on quality websites that would tell you this is the real answer for, say, the density of gold or the density of some other object that you might see or some true value. So the theoretical value is like the real value, and the experimental value is the value you got. You're going to take your theoretical value minus your experimental value. You'll get a number, and then you'll divide it by your theoretical value. Now we take the absolute value here because sometimes your answer might be larger than the theoretical value, and this way you're just not going to get a negative number. Really, that's what the negative would tell you, is that your experimental value was actually above your theoretical value, but really we don't care. It's just how off we were in either direction. And then once we have a numerical value there, we multiply it by 100. That gives us a percent. Let's look at an example. So you might get a problem that says if you calculate the acceleration due to gravity as 9.3 meters per second squared and the true value is 9.8 meters per second squared, what is the percent error? Okay, so the first thing you need to do here is think about which one is theoretical and which one is experimental. Well, your experimental, I told you, was the one you got. So it says if you calculate, so your 9.3 meters per second squared, that's the one that you got. So that is your experimental value, and I've labeled that there with an E. The theoretical value is the true value, so it's 9.8 meters per second squared. And I know sometimes that's confusing because it seems like it's theoretical, it's not real. But it's like what the science textbook or would tell you is the real answer. And it says, what am I looking for? I'm looking for percent error. So my equation, I use percent error as the absolute value, theoretical value, my experimental value divided by theoretical value times 100. And you can use the T's and the E's there when you go ahead and write it. And then I'm into my plug in my answers, find my final answer. So here's theoretical 9.8 minus 9.3. These units will actually match up, so you're still in meters per second. That's great. You're going to divide that answer by 9.8 meters per second squared. And we do 9.8 meters per second divided by when I look at just my units, when I do meters per second squared divided by meters per second squared, that's 1. So they're going to cancel away, which is actually a good thing. So I won't have any units. And then I'm going to multiply that answer by 100. That should give me an answer of 5.1%. And that is my percent error. By the way, that's really good if you only have about a 5.1% error in one of these problems. It means you are doing pretty A-okay with your experimental data. I hope that was helpful. We'll do some practice problems later.